Welcome to Tebi Talks. In this video, we are still looking at more calculations that are concerned with Newton's second law. Our question number 4 says that sand drops at a rate of 100 grams per second onto a horizontal conveyor belt at a steady velocity of 5 centimeters per second. Calculate the force required to keep the belt moving. So that is our question 4. Let us collect the data. From the question, we have the mass rate as 100 grams, but we prefer to have our things in SI units, which will be 100 divided by 1000. That gives us 0.1 kilograms. Then we have the velocity u as 5 centimeters per second. This one we shall also divide it by 100 to get 0.05 meters per second. Now let us try to analyze this question. They are saying sand drops. Assuming this is our container which has the sand. The sand is inside here, and this sand is dropping here. Initially, this is the sand. Now, they are saying that this is a conveyor belt. This is a conveyor belt, and this conveyor belt is moving at a velocity of 0.5 meters per second. Now, if this conveyor belt is moving at 0.05 meters per second, what do we see? We see that the initial horizontal velocity of the sand, u is equal to 0. Now, afterwards, then the final horizontal velocity of the sand, v, is now, it moves at the same speed as the belt. So this is 0.05 meters per second. Now this question said calculate the force required to keep the belt changing. Now this force required, it should be equal to the rate of change. Should be equal to the rate of change of velocity of the sand. So meaning that our force F is equal to the rate. This rate is 0.05, okay? 0.05 times the velocity, the final velocity minus the initial velocity. So this is this was 0.1, sorry. This is 0.1, which is the mass, times the velocity. So we see that this force is the same as 5 times 10 power minus 3 newtons. So this is the force that we needed for the first question. Now let us answer question 5. Question 5 says a hopper drops sand onto a conveyor belt at, again, they have given us mass rate as 75 kilograms per second. If the belt moves at a constant speed, v is 2.20 meters per second. Now, they are saying that we should calculate the force required to keep the conveyor moving. Now, how do we calculate this force? The force required to keep the conveyor moving is the same as V dm dt. So, now this expression is the same as saying that force is equal to m times v minus u out of t. But now, what is falling in differently? This one is uniform. Therefore, a mass divided by time, this one we get mass, it becomes dm dt, the rate at which that mass is falling in there. Therefore, it means that our force here becomes 2.2 times the mass rate, which is 75. Therefore, we get our calculator. We get our calculator, and this is 2.2 times 7.75, and it gives us 165 newtons. This is the force that is required to keep the conveyor moving. So let's look at question 6 also. Question 6 says that a block of metal of mass, we have mass as 2 kilograms, is resting on a frictionless floor, maybe on a frictionless floor. It is struck by a jet releasing water at a rate of, now here we have mass rate equaling to 1 kilogram per second, and the speed v here is 5 meters per second. Now, at a rate of that and at a speed of this, calculate this initial acceleration. They are saying that we calculate the initial acceleration. Now we know that acceleration is got from force over ma. So what does this one tell us? It means that we should be in position to get the force first. But how do we get this force? This force, the rate, the mass, here m dv out of dt should be equaling to v dm out of dt. So our force here is going to be our velocity, which is 5 times the rate, which is 1. So this force of ours becomes, this force becomes 5 newtons. Now, what is acceleration? We have said acceleration is F over m. Therefore, this will be 5 divided by 2, and therefore our acceleration here is 2.5 meters per second. Now, this is in fact per second squared. Those are the units of acceleration.